Momentum. What's meant by momentum? Momentum, it is the product of mass and velocity. If we have a moving object, so it has a momentum. Any moving object has a momentum. Object at rest has no momentum. What's meant by momentum? Momentum, from the point of physics view, momentum is the product of mass and velocity. How are we going to convert it like this? We are going to remove and we are going to add multiply. So momentum is the product of mass and velocity. Momentum is the vector physical quantity. Vector physical quantity means it has magnitude and direction. In order to be fully defined, we need to know magnitude and direction. Momentum in a symbolic equation, the symbol for momentum is P, and the symbol of mass is M, the symbol of velocity is V. Momentum, as we said, is a vector physical quantity. It depends on the velocity direction, since it is the product of mass and velocity. We need to know the unit of momentum. Unit of momentum is the same like unit of mass and unit of velocity. Here the unit of mass is kilogram in SI unit of velocity in SI unit is meter per second. So momentum unit is kilogram meter per second. Let's analyze the equation. We have momentum, which is equal to mass by velocity. Momentum is directly proportional to mass at constant velocity. It means by increasing the mass to the double, the momentum also increase to the double. And by decreasing mass to the double, momentum decrease to the double. The relation between momentum and velocity at constant mass is also proportional. Proportional means momentum is proportional to velocity at constant mass. By increasing velocity to the double, momentum increases to the double, and vice versa. Let's find the change in momentum. If we have a moving object and we need to find the change of momentum, let's assume we have a car, and this car is moving with, it has a mass M and moving with velocity V. Let's assume it's moving with initial velocity U. After a while, after covering a certain distance, the velocity of the car becomes V and still has the same mass. Let's find the initial momentum. The initial momentum is equal to mass times initial velocity. The final momentum is equal to mass times the final velocity. If we are going to find the change in momentum, the change in momentum is equal to final momentum minus initial momentum. Final momentum is mv minus initial momentum is mu. I'm going to take m constant. Most of the time, the change in the mass is very, very small if we have a car due to the consumption of fuel, but we can ignore it, or we are going to ignore it. So m is equal to v minus u. Or we can say the change in momentum is equal to mass by change in velocity. If we are going to calculate the force causing this motion, how we are going to find the force? According to Newton's second law, it has another statement related to the change in momentum. This statement says that the resultant force acting on a moving object equals to the rate of a change in momentum. According to Newton's second law, the resultant force acting on a moving object equals to what? Equals to the rate of change in momentum. Equals to the rate of change in momentum. We need to convert this into a mathematical formula. You are going to find that the resultant force is Fr equals to the rate of change in momentum. The rate means delta T, or the rate of change. the rate of change in linear momentum, we said, so delta P over delta T. We already deduced the change in momentum, which is mass times the change in velocity over change in time. Look at delta V over delta T. It will remind you with what? It will remind us with the acceleration. Acceleration is equal to delta V over delta T. If we are going to return back to the resultant force, you will find that the resultant force equals to mass times acceleration, and here is Newton second law. Here is the mass in kilogram, here is the acceleration in meter per second square, and you will find that the resultant force is measured in Newton or kilogram meter per second squared. We are going to move to the collisions, but we are going to postpone this to a next episode, inshallah. Until I meet you again, I wish you all the best. Wassalamu alaikum wa rahmatullahi wa barakatuh.